This illustration deals with increased in size, 250.122B as in boy, an exception. The purpose of the change here was to provide a revision to what this section was really requiring. And the revision has been made to clarify the requirements for increasing the size of ungrounded conductors for any reason other than required by 310.15B or 310.15C. If a wire type equipment grounding conductor is installed, the wire type equipment grounding conductor or conductors shall be increased in size proportionally to the increase of the circular mill rating of ungrounded conductors. A new exception now has been added to permit the grounding electrode conductor or conductors to be sized by a qualified person and their size to provide an effective ground fault path in accordance with 250.4A5 and 250.4B4. In other words, this was engineers wanted this back, when we first upgraded and updated the Article 250 and rewrote it. They said, look, we can prove that we have an effective ground fault path, but we can't prove necessarily that system's effectively grounded throughout. So the engineers said, let's say effective ground fault path. So, and this is what they were kind of wanting to accomplish here. Now, notice that this is now dealing with voltage drop, and if you don't mind, first I'm gonna look at this sub panel here at the top, and it says 140 amps, continuous load. We calculate the load and we come up with a number 2-aught connected to a 175 amp main. That complies with table 310.16 and table 240.6A. And then if you look at the bottom, this says, due to the voltage drop, conductors in the feeder is increased to supply a calculated load. Therefore, the equipment ground should be increased also. And so we went increased from a number 2-aught connected to a 175 amp main in the service panel to 3-aught because of the voltage drop. And you can see that the overcurrent device listed there, pointing to it, we would have a 175 amp, and it would comply with 215.3 for the 2-aught. But since we increased it to 3-aught, it still would be a 175 amp main. But when we reviewed in the step 1 in the call-out information, in the boxed in information, 250.122B as in boy, and table 250.122 is addressed, and table 310.16. So the 175 amp load required a 2-aught that's good for 175 amp, and our table 250.122. And since the load in the overcurrent device is over 100 amp, then we know it's 75 degrees C terminals. Now, that's 110.14C as in car. Now, we increase it to 3-aught because of the voltage drop, step 2. And then step 3, 250.122B, along with table 8 to chapter 9 says, now let's look at the math. The 2-aught, based on a 175 amp main from table 8 to chapter 9, was 133,100 circular mil. The 3-aught now, due to voltage drop, not load, was 167,800 circular mil. But the 175 amp main per table 250.122 was a number 6, and its circular mil rating was 26,240 from table 8 to chapter 9. So step 4, we were going to determine what our multiplier would be to determine if we need to increase that equipment ground. So step 4, we took the 167,800 for the 3/0, divided it by the circular mill rating of the 2/0, which is 133,100, and our multiplier now was 1.260, 1.2607062. Now, we'll go to step 5, and we take that multiplier times the original size of the equipment grounding conductor, which was number 6, 26,240. We do the math of multiply the multiplier times it. We come up with 33,081 circular mil. Now we go to Table 8 to Chapter 9 again at the back of the code book. We find that 33,081 requires a number 4. So a number 4 is good for 41,470, and that is that will take care of the 33,081. Now notice the size of the equipment grounding conductor based upon the voltage drop would be increased to number 4 and not number 6. Now we have complied with the exception and everything to 250.122b. Now, the way this kind of reads to me now is that, correction factors and adjustment factors are not necessarily included here. Look at note 1. Equipment grounds should be permitted to be sized by a qualified person as outlined in 250.122b exception to provide an effective ground fault path. Now, what does that mean by 250.4a5? Well, let's say that you had 250 kc mil coming in, and say you terminated a 250 amp main. The 250 kc mil per table, 250.102c1, would require that grounded conductor coming in to be at least number 2. Now you got an effective ground fault path. You'd say, well, no, it has to be 2/0 because we have a lot of neutral load. Then the 2/0's more than adequate to take care of the number 2. So 220.61 rule there again. See that we've kind of repetitious told you that because of the revisions in the code. Now, the next thing, you want to make sure that the equipment ground run over to this sub panel is adequate to provide a low impedance path. So if you had a 175 amp main, that would be number 6, based upon the 2/0. But we increased it to 3/0 because of the voltage drop, so you had to increase it to number 4 based upon what 3/0 could carry over here. We needed the number 4 to take back here to the panel and then return on the grounded conductor back to the transformer. And that's what the engineers wanted. Said we can go before a plan checker, we can talk to an inspector, and we can all be on the same page that we are providing as engineers an effective ground fault path and not that old business that used to be in the code, effectively grounded. Now, basically that is what this revision is all about.